All right, in 1.2, we're going to talk about data and how we sample it correctly. Okay, the first thing is we need to be able to classify some data. The first set of vocab here is quantitative or numerical data is data that consists of numbers representing counts or measurements. Height, weight, years of education, GPA, test scores, anything averageable. If that's a word, averageable numbers, okay? Now the opposite of numerical data would be what we call categorical. All right, that consists of names or labels that are not numbers representing counts or measurements. So like gender, hometown, ethnicity, zip code, a jersey number. Okay, you can't average when nobody averages their jerseys. That doesn't work. But categorical is the name for that kind of data. Now, within quantitative, it's like quantitative then breaks into two kinds, okay? We have what happens to be called discrete. Discrete data. It's quantitative data that results when the number of possible values is either a finite number or a countable number, okay? Countable number. Integers from 1 to 0. A thing to remember with discrete is that there's gaps between it. Like if I count 1 puppy and 2 puppies, 3 puppies, that's fine, but there's no in between. It's not 1.125 puppies or 1.15 puppies. There's a gap there are gaps in discrete data. Now the opposite of discrete data is when there's no gaps is what we call continuous data. It's quantitative data which results when there are infinitely possible values corresponding to some scale that covers a range of values without gaps, okay, no gaps, interruptions or jumps, okay? So for instance, all the values between 0 and 1, I could do 0.0001, 0.00002, and I could go on. There's infinitely many numbers I could put between 0 and 1 if I added a bunch of decimals. So continuous data is kind of their decimal version. Discretes are your integers, meaning whole numbers. Now, sampling methods. All right, here's another thing we got to remember. If you recall, in the previous video, I talked about the population is something we want to know information about, but we're not going to get to every member of the population, so we have to take a sample. And we want that sample to be good and representative of the population. If it's not, then any information we gather from the sample, we cannot use to make inferences about the population. So that's the goal here. Now, so let's talk about sampling methods. How do we get a good sample? If you don't have a good sample, your information is not helpful. Okay? So some more vocab for you. A simple random sample. It's a sample of n number of subjects selected in such a way that every possible sample of the same size has the same chance of being chosen. It's a mouthful. A sample is selected in such a way that every possible sample of the same size n, notice this sample size matters, can be chosen. Now, all different kinds, if it's just can be simple, we call it simple random sample and we abbreviate SRS. Now, more specific kinds first one is a systematic, in which it's a sample where the researcher selects some starting point and then selects every 10th element in the population of n, okay? Every kth element, or like 10th. So every other row, every 10th person, all different ways you could be systematic, but there's a system to it, all right? The next one is called stratified. Stratified sample is a sample in which the researcher subdivides the population into at least 2 subgroups, which we also call strata, and then draws a sample from each subgroup, okay? So if I have groupings, let's see, freshman, sophomore, junior, seniors, I put them in different groupings and I choose a little bit from each one, okay? That would be a stratified. So it's some from all the groups, okay? Sum from all. Another sample is called the cluster sample. It's similar, but catch this. It's a sample in which the researcher first divides population into sections or clusters, and then randomly selects all the members from some of the clusters. So while stratified is sum from all, so you pick some from each group, you pick all from some, okay? So you divide students into middle schools, and I would sample everyone in one middle school. That would give me a sample of middle schoolers, okay? All from some. So all is a key word to pick up on when you're reading a scenario and trying to decide what's the sampling method here. All right, the next kind of sampling method is called a convenience sample. It's a sample in which the researcher simply uses results that are very easy to get, it's not valid, and it will likely result in biased data, which we'll talk about in a little bit, okay? It's not valid. Convenience sampling is, it's easy, right? Think the mall and the clipboard scenario. If you're at the mall and there's someone at the clipboard wanting to get a survey, that's convenient. They just stand there and people come to them. But that data is not very good because it's focusing only on people in the mall. So that's where the bias comes in, and we'll get there. But convenience is when it's just easy. It's not a good cross-section of the entire population. Remember, that's the goal here. All right, so let's look at this. Taxpayers in a population are listed in order of increasing income. In each situation, determine which type of sampling method was used. All right? So, A, a sample is selected by first separating the taxpayers into 4 groups based on income, then randomly selecting 50 people from each group. So I have 4 groups, and I take 50 from each. So what am I doing? I'm taking sum from all. That would make it stratified. Okay. B, a sample is selected by randomly choosing one of the first 100 names, then choosing every 100th name in the list from that point forward. Okay, so this is the indication of a system going on right here. So that's simply a systematic sample. A random number generator in Excel is used to select a sample size of 100. Okay, it's just a random number generator. There's no rhyme or reason to it, but it is random. So we would just call that a simple random sample. Okay, it is valid, it is random. Okay. Now we start talking about what happens if there's a problem with our sample, and that problem is called bias. It occurs if the results of the sample are not representative of the population, okay? We want good samples, but sometimes they come up biased. So let's talk about some reasons it can become biased, all right? Sources of bias in sampling. Well, the first one is called sampling bias. That means the technique that was used to obtain the individuals in the sample tends to favor one part of the population over another. For instance, that convenience sampling that I told you about in the mall, that does not represent the whole population very well, all right? Another type of sampling bias is a thing called undercoverage, where a portion of one segment of the population is lower in the sample than it is in the population, okay? So that means like there's a whole group of the population that did not even get asked their opinion on the thing. For instance, if I only surveyed people with landlines, I didn't talk to anyone with cell phones. Well, what about all the people with cell phones? Their voice was not heard. So that results in what we call undercoverage. These are the unheard voices, okay? The unheard ones. They didn't get their voice heard. All right. Now, non-response bias occurs when individuals are selected in the sample who do not respond to a survey have different opinions from those who do, okay? Now, non-response. Example, they do not respond, or the interviewer cannot contact them. okay? They choose not to respond voluntarily, that's their choice, right? And they can't respond. Now, non-response is happens a lot in what we call a voluntary response sample. That's another sampling technique that's not great. It creates bias. Voluntary response sample is like an online poll or survey where people volunteer their voice to be heard. Okay? Well, only people who watch that show would vote, right? People who don't watch the show don't know there's a vote out there that needs to be done, so their voice is not heard. Okay? So the bias comes in with a voluntary response sample. Not a good idea. Now, how to control non-response? Well, you can call people back, you can use rewards, you can use incentives. All those things are possible, but they all take time and money. So you want to make sure your sampling method is good, valid, and not going to create a need for more money. Now, response bias is when people do answer the survey, but their answers do not reflect the true feelings. All right, so a lot of ways this can happen. They did answer. Non-response means they didn't answer. Response means they did answer, but there's a problem with what they said. Okay, so there's a lot of possible problems. First thing is an interview error. A trained interviewer is essential to obtain accurate information. They will have the skill necessary to elicit responses and make the interviewee feel comfortable. So the interviewer could be intimidating, or the interviewer could be swaying their opinion on things, depending on who they are. If it's the principal asking a question versus the student, you may answer differently. So think about that. Principal versus student. Your answers may change, may not. Okay, the next is misrepresented answers. Some survey questions result in responses that misrepresent facts or flat out lies. For example, when asked salaries of graduates, reports are inflated. People want to look good, so they're going to inflate their answers. Another example, when asked how many push-ups you can do, some people might exaggerate. I know it's hard to believe, but it could happen. So this is your idea of exaggeration. Misrepresented answers. All right, the next one is what we call loaded questions. The wording of a presentation or the questions plays a large role in the type of response given to the question. The way a question is worded can lead to response bias. Sorry for that hyphen, it shouldn't be there. So they must always be asked in a balanced form. That's really important when you word your questions. You don't want to be leading in the question. For example, do you think the practice of aborting innocent unborn children should be made illegal? Versus, do you think the practice of aborting unborn children should be made illegal or remain legal? All right? The way a question is worded can definitely sway someone's answer. Not to mention the tone of the question, so keep that in mind. The ordering of the questions can affect someone's answer. Okay? Questions can be unintentionally loaded by the order of items being considered. Many surveys rearrange the order of the questions within a questionnaire so that the responses are not affected by prior questions. This is a very thoughtful process when you make a questionnaire. You want to make sure you don't lead an answer one way or the other. And then lastly, a data entry error. Not technically a result of response bias, but data entry errors can happen, and they will lead to results that are not representative of the population. For instance, most data gets put into computers, and it's really easy to type 93 instead of 39. It just happens, all right? So, common problems to be aware of. Problems with the samples. Well, the sample must be representative of the population. That is super, super important. A sample that is not representative of the population is biased. Biased samples that are not representative of the population give results that are inaccurate and invalid. Okay? Other problems, self-selected samples, okay? Responses only by people who choose to respond, such as call-in surveys, are often unreliable. We call those voluntary response samples. unreliable, okay? Sample size issues. Samples that are too small may be unreliable. Larger samples are better if possible. In some situations, having small samples is unavoidable and can still be used to draw conclusions, like crash testing cars. You don't want to have to crash test thousands of cars to have a conclusion. So in this case, it would be acceptable to have a small sample. Or medical testing for rare conditions. You don't want to have to expose thousands of people to something. It's just not ethical. All right, undue influence. Collecting data or asking questions in a way that influences the response. Okay, that could be tone of voice, that could be authority figures, all things connected to potentially the interviewer. Non-response or refusal of a subject to participate. The collective responses may no longer be representative of a population. Often people with strong positive or negative opinions may answer surveys, which can affect the results, okay? So this is that non-response thing. People may not respond, but people who do respond usually have a very strong opinion. And you can sometimes see that even on Yelp, okay? Causality, okay? This is not casualty, it's cause. Think cause. Causality. A relationship between two variables does not mean that one causes the other to occur. They may be related, or what we call correlated, because of their relationship through a different variable, but does not mean that they cause one another. Okay, so be very careful. Self-funded or self-interest studies. A study performed by a person or an organization in order to support their claim. Is the study impartial? You have to read the study carefully to evaluate. Do not automatically assume that the study is good, but do not automatically assume the study is bad. Evaluate on its own merits and the work done. So always be cautious of things like that. Look who funded a study if you're reading one to see if that could be an effect in the bias. Misleading use of data. Improperly displayed graphs, incomplete data, or lack of context. It can happen, and it does happen. And then lastly, confounding data. This is when the effects of multiple factors on a response cannot be separated. Confounding makes it difficult or impossible to draw valid conclusions about the effect of each factor. Confounding is kind of when things are blurry, like if you're looking at weight loss. There's a lot of things that factor weight loss, right? The diet, the exercise, health conditions, age, gender, and you could go on and on and on. All of these variables will affect a weight loss, or the rate of weight loss. So these are called confounding factors. You can't separate them out. All right, so let's try some example problems. Classify each variable as qualitative or quantitative. Okay, this goes back to the very beginning thing we talked about. Okay, nation of origin. By the way, feel free to pause the video, try these, and then come back and check them with my answers, okay? Nation of origin would be qualitative. Number of siblings. Number would mean quantitative. Grams of carbohydrates in a donut. That would be quantitative. Number on a football player's jersey. This would be qualitative. Number of unpopped kernels in a bag of ACT popcorn. That would be quantitative. Assessed value of a house. That would be a number, so that would make it quantitative. A phone number. Well, a phone number is more of a label, so we would call that qualitative. What about a student ID number? Again, that's more of a label, so we would call that qualitative. All right? Determine whether the quantitative data is discrete or continuous. Remember, discrete means gaps, and continuous means no gaps. Discrete also could mean counted versions, and continuous I like to think of as measurements. Okay, so look, Runs scored in a season by Derek Jeter. Well, we count runs, so this would be discrete. Volume of water lost each day through a leaky faucet. Well, volume is a measurement, so this would be continuous. Length in seconds. That's a key that it's a measurement of a country song. That's continuous. Number of sequoia trees in a randomly selected acre of Yosemite National Park. Well, we count trees in whole numbers, so that would have to be discrete. Okay, so let's look at this and see if we can identify sampling methods. To estimate the percentage of defects in a recent manufacturing batch, a quality control manager at Intel selects every 8th chip, there's a clue, that comes off the assembly line, starting with the 3rd until she gets a sample of 140. That every 8th chip is a clue that it is systematic. B, to determine the prevalence of human growth hormone use among high school varsity baseball players, the State Athletic Commission randomly selects 50 high schools. All the members of the selected high school varsity baseball teams are tested. So here's a clue right here. All the members, okay? So this is all of some. We know there's more than 50 high schools out there, but we're taking all of some. That would make it a cluster. So we assume more than 50 high schools exist. C, a member of Congress wishes to determine her constituency's opinion regarding estate taxes. She divides her constituency into 3 groups. Here we go, low income, middle, and upper. Then she takes a simple random sample of households from each income class. So we have low income, middle income, and upper income. And then she takes a sample here, takes a sample here, and takes a sample here, simple random sample. So she's taking sum from all the groups. So this is a sum from all, which makes it stratified. Okay? Example 4, types of bias. A retail store manager wants to conduct a study regarding the shopping habits of its customers. He selects the first 60 customers who enter his store on a Saturday morning. What kind of bias would that be? Well, that would be a sampling bias. More specifically, what did he do? He did a convenience sample. He did what was easy and convenient. It's not random, it's convenient. Okay? So there is sampling bias there. One last example here. An anti-gun advocate wants to estimate the percentage of people who favor stricter gun laws. He conducts a nationwide survey of 1,203 randomly selected adults 18 and older. The interviewer asks the respondents, do you favor harsher penalties for individuals who sell guns illegally? All right, so we're asking ourselves, what kind of bias is this? Is this sampling bias, non-response bias, or response bias? I would say this would be response bias. Okay, and more specifically, it's the wording of the question that's a problem. Okay, I gave you lots of different types of response bias, but this one is specifically a wording of the question. So sampling bias, response bias, and then there's non-response bias that occurs also. But we'll look at some more examples when we get into class. I know this video is kind of long, but hopefully it's been very informative.